Normandy, June 1944. A single strand of wire stretched at ankle height across a rutted farm road would stop 56 tons of German armor in under 3 seconds. The engineer's name was Corporal James McAllister, 23 years old, former electrician from Pittsburgh. He carried no explosives that morning, no bazooka, no anti-tank mines, just a coil of communications wire and an idea born from desperation. The Tiger I was already a legend. 68 tons when fully loaded. An 88mm gun that could punch through 4 inches of sloped armor at 1,000 meters. Frontal plating so thick that American Sherman crews called engagement at range a suicide mission. Production began in August 1942. By D-Day, fewer than 1,400 had been built. Each one cost 650,000 Reichsmarks. Each one required 300,000 man-hours. Germany couldn't afford to lose them. The Allies couldn't afford to face them. The mathematics were brutal. A single Tiger could disable 5 Shermans before taking a penetrating hit. The Sherman's 75mm gun required point-blank range and a flank shot to threaten the Tiger's armor. Even then, success was uncertain. The Tiger's tracks were 18 inches wide. Its Maybach HL-230 P45 engine generated 700 horsepower. It could climb a 35-degree slope, ford rivers 4 feet deep, rotate its turret a full 360 degrees in under a minute. But it had a weakness. Every tank did. The Germans called it the Laufwerk, the running gear. The intricate system of overlapping road wheels, drive sprockets, and track links that translated engine power into movement. On the Tiger, this system was a masterpiece of engineering and a maintenance nightmare. 9 road wheels per side, overlapping in 3 rows, interleaved for weight distribution and ride quality. Brilliant in theory, catastrophic in mug, snow, or mechanical failure. The interleaving wasn't arbitrary. German engineers had calculated the optimal arrangement. Each wheel bore a precise percentage of the vehicle's total weight. The overlapping pattern distributed stress evenly across the track. This reduced ground pressure to 14.8 pounds per square inch, lower than many lighter tanks. It allowed the Tiger to traverse soft ground that would bog down simpler designs. It gave the crew a smoother ride, improving gun accuracy on the move. But the complexity had costs. Each overlapping wheel added friction to the system. More points of contact meant more opportunities for debris to lodge in the mechanism. In the mud of the Eastern Front, the gaps between wheels filled with dirt that froze overnight. Tank crews spent hours each morning chipping ice from the running gear. In the desert, sand ground down the rubber tire rings that cushioned each wheel. Replacement required disassembling half the suspension. On the Tiger, changing an inner road wheel meant removing up to 8 outer wheels first. McAllister had seen a Tiger up close exactly once, 4 days after landing on Omaha Beach. His unit, a combat engineer company attached to the 1st Infantry Division, had been tasked with clearing roadblocks outside Marigny. The Tiger had been abandoned, its engine dead from fuel starvation. McAllister had climbed onto the hull, touched the cold armor, studied the tracks, counted the wheels, measured the gaps with his hands. He noticed something the tank's designers might have missed. The overlapping wheels created narrow channels between their edges, tight vertical spaces where the wheels nearly touched but didn't quite. Each gap was perhaps 3 inches wide, just enough clearance for the wheels to rotate freely, just narrow enough to trap objects of certain dimensions. A stone wedged between 2 wheels had cracked the rubber tire on one road wheel. A length of chain caught in the drive sprocket had torn 3 track links before the crew cut it free. McAllister had run his fingers along the track assembly, felt the tension in the system, calculated mentally how much force held everything together. The track itself was under constant stress. Each link carried a portion of the tank's weight. The drive sprocket at the rear pulled the track forward. The idler wheel at the front maintained tension. The 9 road wheels in between supported the load. Remove any single component, and the system failed. He noticed something else. The Tiger's tracks were wider than standard. Each link weighed 11 pounds. The entire track assembly on one side weighed nearly 2,000 pounds. That mass multiplied by rotational speed generated enormous momentum. Once the tracks were moving, they resisted stopping. This was intentional. It helped the Tiger maintain forward momentum over obstacles. But it also meant that if something jammed the mechanism, the momentum would amplify the damage before the driver could react. McAllister filed these observations away. 3 weeks later, his company was dug in along a hedgerow south of Carentan. The hedgerows of Normandy were older than the war, older than nations. Earth berms 4 feet high, topped with hawthorn and bramble, dividing the countryside into a claustrophobic maze. Each field was a fortress, each gap a killing ground. The bocage turned fluid maneuver into grinding attrition. Infantry advanced by meters. Tanks became blind. Artillery ruled everything. The Americans had trained for beach assaults, open ground tactics, combined arms operations on terrain that resembled Kansas or Texas. They hadn't trained for this. The hedgerows negated every advantage. Armor couldn't maneuver. Air support couldn't identify targets through the canopy. Artillery was effective, but slow. Infantry fought yard by yard through vegetation so dense that visibility dropped to 20 feet. The Germans understood this terrain. They'd had 4 years to prepare. Every crossroads was pre-registered for mortar fire. Every gap in the hedgerows was covered by interlocking machine gun positions. They didn't need to win. They just needed to delay. Every day the Allies spent in the bocage was another day to reinforce the interior, another day to move the panzer divisions into position, another day to fortify Caen and Saint-Lô. McAllister's platoon had been in the line for 18 days. They'd advanced 2 miles, lost 11 men. The replacements were green, farm boys from Iowa and factory workers from Detroit who'd been in Europe for less than a week. They didn't know the sound of a Nebelwerfer launch, couldn't distinguish German machine gun fire from American, froze when mortars started falling. McAllister and the other veterans tried to keep them alive, taught them to dig deeper, stay lower, move faster. Most learned. Some didn't live long enough. June 28th, 5:30 in the morning. The Germans counterattacked. Not a probe, not a spoiling action. A full-strength armored thrust aimed at splitting the American beachhead. Panzer Grenadiers riding on half-tracks, infantry in the hedgerows, and rolling at the spearhead, 4 Tiger tanks from the 101st Heavy Panzer Battalion. Intelligence had warned that Tigers were in the sector. Radio intercepts had identified the unit 3 days earlier. Air reconnaissance had spotted the tanks in a tree line 6 kilometers south. But knowing Tigers were present and facing them were different experiences. The intercepts didn't convey the sound. The reconnaissance photos didn't capture the psychological weight of watching 4 gray monsters emerge from morning fog. McAllister heard them before he saw them. The deep guttural growl of the Maybach engines. The metallic clank of tracks on cobblestone. The ground trembling under their weight. His platoon was dug in along a sunken road that ran perpendicular to the German advance. 32 men, 2 bazookas, 3 Springfield rifles per foxhole. Orders to hold until relieved or overrun. The orders were realistic. No one expected them to stop 4 Tigers. The mission was to delay, cause casualties, force the Germans to deploy, buy time for artillery to range in and armor to reposition. If the platoon held for 30 minutes, it would be considered a success. If they held for an hour, it would be remarkable. Survival was optional. The Tigers appeared at 6:15, 4 gray shapes emerging from the morning mist, turrets traversing slowly, main guns elevated to optimal angle for engaging dug-in infantry. They moved in a loose diamond formation, staying to the roads where the ground was firmest. The lead tank was 200 meters out when it fired. The shell hit a farmhouse to McAllister's left. Stone and timber exploded into fragments. The concussion knocked dust from the hedgerow. The second Tiger fired, then the third. Suppressive fire to keep American heads down while the infantry advanced. The sound was distinctive. The 88mm QWK-36 gun had a flat, sharp report, not the booming roar of American artillery, something harder, more percussive. Each shot was followed by the whistle of the shell in flight, then the crack of impact. High explosive rounds, not armor-piercing. The Tigers weren't hunting tanks, they were clearing infantry. The tactics were methodical. Shell the hedgerow, advance 50 meters, shell again. Let the infantry sweep the position, move to the next objective. The bazookas were useless at this range. McAllister knew the math. The M1 bazooka could penetrate 3 inches of armor under ideal conditions. Effective range was 100 meters. Beyond that, accuracy dropped and the shaped charge jet dispersed. The Tiger's frontal armor was 4 inches thick, angled at 9 degrees, hardened through a face-hardening process that made the outer layer resistant to penetration. Even a perfect hit at optimal range would likely bounce. The only vulnerable points were the engine deck and the lower rear hull. To hit those, you had to let the tank pass, let it roll over your position, rise up behind it, fire at a machine designed to kill you. None of McAllister's men were going to get that chance. The Tigers would shell the hedgerow to rubble, then machine gun any survivors. Standard doctrine, proven tactics. The Germans had done it 1,000 times in Russia, against troops more experienced than this American platoon. Against defensive positions more sophisticated than foxholes in a hedgerow. They'd do it here, and it would work. McAllister looked at the sunken road. It was 15 feet wide, hard-packed dirt with ruts from farm carts. The only route through this section of bocage that could support a Tiger's weight. The hedgerows on either side were too dense, the earth too soft. Engineers had checked 3 days earlier. Anything heavier than a half-track would bog down within 20 feet. The tanks would have to come down this road single file at walking speed, blind to their flanks. This was where the platoon was supposed to make it stand. 2 bazookas positioned to fire on the engine decks as the Tigers passed. Infantry with grenades to attack the vision ports. A forlorn hope, desperation tactics. McAllister had watched crews train with the bazooka. It was an effective weapon against the side armor of a Panzer IV, marginal against a Panther, suicide against a Tiger. The shaped charge warhead needed to strike at 90 degrees to the armor plate. Any deflection reduced annihilation. The Tiger's armor was angled, textured, designed to deflect. He looked at his hands. He was still holding the coil of communications wire. 300 feet of braided steel cable. Standard field telephone wire, 1/8 inch thick. Tensile strength rated for 200 pounds. Nowhere near strong enough to stop a tank. You could wrap it around a Tiger's gun barrel and the tank wouldn't notice. You could drape it across the hull and the crew would brush it off. Wire was for communications, not combat. But that wasn't what he needed it to do. McAllister ran. He sprinted 50 meters down the sunken road, staying low in the depression where the Tiger gunners couldn't see him. The road curved slightly, creating a blind spot. He found what he needed. 2 stout fence posts on opposite sides of the road, weathered oak driven deep for a gate that no longer existed. The posts were perhaps 18 inches in diameter, sunk 3 feet into the ground. solid enough. He tied one end of the wire to the left post, wrapped it 3 times, used a triple fisherman knot, something his father had taught him for securing electrical conduit. The knot wouldn't slip under load. He pulled the wire across the road, kept it taut, ankle height, maybe 8 inches off the ground. Low enough to catch the tiger's running gear, high enough not to drag in the dirt. He tied the other end to the right post. Same technique, 3 wraps, maximum tension. The wire was taut enough to hum when he plucked it. The wire was almost invisible in the early morning shadow of the hedgerow. He had 90 seconds before the lead tiger reached his position. McAllister scrambled back to his foxhole, told no one what he had done. There was no time to explain, no certainty it would work. The idea was absurd. A strand of wire against 56 tons of armor. It violated every principle of anti-tank warfare. Mines worked through explosive force, bazookas through shaped charge penetration, artillery through kinetic energy and overpressure. Wire had none of these things. It was a nuisance, a delay, something to be brushed aside.
But wire could jam. That was the theory. If the wire caught in the overlapping wheels, if the angle was right, if the tension held, it might jam the mechanism, lock the track, immobilize the tank. A slim chance. But the alternative was watching 4 tigers roll through the platoon's position and kill everyone in the hedgerow. The lead tiger entered the sunken road at 6:20. It moved at walking speed, 4 kilometers per hour, engine throttled down to reduce fuel consumption. The commander's hatch was open. An officer in black Panzer uniform stood half exposed, scanning for threats. Standard operating procedure in close terrain. The closed hatches reduced visibility to dangerous levels. Better to risk small arms fire than blunder into an ambush. The main gun was traversed left, covering the hedgerow where McAllister's platoon was hidden. The coaxial machine gun was manned, ready to rake the tree line. The tank was 20 meters from the wire. 15 meters. 10. McAllister held his breath. The front left drive sprocket hit the wire. Physics took over. The wire didn't break. The fence posts held. The cable was thinner than the gap between the tiger's overlapping road wheels, but the angle was wrong. Instead of slipping through, the wire caught on the bottom edge of the third road wheel. The forward momentum of the tank pulled the wire upward and inward. It wrapped around the wheel in a fraction of a second. 1 loop, 2 loops, 3. The interleaved wheels created a self-feeding trap. As the wheel rotated, it drew more wire into the mechanism. The wire jammed between the second and third wheels. It happened faster than the driver could react. The wire wedged into the narrow gap. The rubber tire on the second wheel compressed against the wire. The third wheel pulled from the opposite direction. The wire bit into the rubber. Found purchase. The tension increased exponentially. 200 pounds of tensile strength multiplied by the mechanical advantage of the rotating wheels. The wire acted like a ratchet. Each rotation drew it tighter. The wheels locked together. The entire left side track assembly seized. The right track kept moving. The tiger pivoted violently to the left. The driver felt the loss of control through the steering levers. He reacted instinctively. Gunned the engine. Wrong decision. The Maybach roared. 700 horsepower tried to drag the locked track forward. The right track dug into the road surface, threw up dirt. The tiger slewed sideways. The locked left track acted like a pivot point. The tank rotated 15 degrees in 2 seconds. Something in the loutwork snapped. Not the wire. The wire held. It was a suspension arm that failed first. The torsion bar connecting the third road wheel to the hull fractured under the uneven load. Then a mounting bracket. The tiger lurched, stopped. The engine screamed. Black smoke poured from the exhaust as the governor tried to compensate for the sudden load. The driver killed the engine before it damaged itself further. Total elapsed time, 2.8 seconds. The Tiger sat motionless in the sunken road, canted at a 15-degree angle to the left, blocking the advance of the 3 tanks behind it. The commander of the second Tiger tried to push the lead tank clear. He closed to within 5 meters, lowered his blade, and revved his engine. The plan was to shove the disabled tank forward enough to create a gap, maybe push it off the road entirely. The second Tiger's engine roared. Its tracks spun, tore up the road surface, threw up debris. The disabled tank didn't budge. Its locked left track acted like an anchor. The weight of the hull pressed down through the seized mechanism. 56 tons distributed across 8 road wheels. The friction was enormous. After 30 seconds, the tracks on the second Tiger began to slip. Rubber tire rings smoked. The commander gave up before he damaged his own vehicle. The Germans were now stationary targets in a known location. McAllister's lieutenant was already on the radio. Fire mission called in at 6:26. Coordinates transmitted. Adjust fire. 3 batteries of 105mm howitzers acknowledged. Tubes elevated. Propellant charges loaded. High explosive shells. Variable time fuses set for airburst. Target: enemy infantry in the hedgerows flanking the tanks, not the tanks themselves. American artillery couldn't penetrate a Tiger's armor from above, but they could kill the infantry supporting the tanks.
Airburst rounds impacted at 6:30. The shells burst 20 feet above the hedgerow. Fragmentation sprayed downward. White phosphorus ignited the dry vegetation. The Panzer Grenadiers broke and scattered. Some tried to stay with the tanks, took cover behind the hulls. Others fled back down the road. Within 2 minutes, the Tigers were alone. Without infantry, they were blind and vulnerable. The crew-served weapons couldn't depress low enough to engage targets at the base of the hulls. The machine guns had limited traverse. A determined infantryman with a satchel charge could approach from dead ground and destroy the tank. The Tigers were worth more than the men supporting them. That was the cold mathematics of German armor doctrine in 1944. Trained tankers were irreplaceable. Each crew required months of training. Each Tiger represented 500,000 Reichsmarks and thousands of man-hours. Losing a tank was a strategic blow. Losing infantry was a tactical inconvenience. So when the artillery started falling, the Panzer Grenadiers scattered. They'd regroup later. The Tigers would survive. Except now the Tigers couldn't move. A Sherman platoon arrived at 6:45. 4 M4A1 tanks with 76mm high-velocity guns. Not the old 75mm pop guns that bounced off Tiger armor. The new guns. Longer barrels, higher muzzle velocity, capable of penetrating 4 inches of armor at 500 meters under optimal conditions. The Shermans approached from the east using the hedgerows for cover. Their commanders knew the Tigers' location, knew they were immobilized, knew the German infantry had scattered. The Shermans didn't engage the lead Tiger. They bypassed it, maneuvered through gaps in the bocage that the Tigers couldn't navigate. Lighter tanks, simpler suspension, narrower tracks. They reached firing positions 300 meters behind the German formation. The Tigers were facing the wrong direction. Their turrets could traverse, but slowly. 62 seconds for a full rotation. The Shermans had 30 seconds to fire before the Tigers could bring their main guns to bear. At 6:50, all 4 Shermans fired simultaneously. Not at the frontal armor, not even at the side plates. They targeted the rearmost Tiger's engine deck, the thinnest armor on the vehicle. 25 millimeters angled, but not steeply. 3 shells penetrated, punched through the deck and into the engine compartment. 1 struck the fuel tanks. The Tiger erupted. Not a Hollywood explosion, a rapid expansion of burning fuel and smoke. Flames poured from the engine grills. Black smoke from burning rubber and oil. The crew had 15 seconds to evacuate before the ammunition cooked off. 5 men emerged. 3 from the turret hatches, 2 from the hull. 2 of them were on fire. They rolled in the dirt, screaming. The remaining Tigers surrendered at 7 o'clock. Crews emerged with hands raised, white undershirts tied to radio antennas. The mathematics had shifted. 3 Tigers trapped on a narrow road. American armor behind them. Artillery zeroed in. Infantry closing. No infantry support. No way to maneuver. No way to win. Surrender was the rational choice. Live to be exchanged or repatriation. Better than burning. The disabled lead Tiger was towed to a field workshop for analysis. American engineers swarmed over it, photographed every detail, measured armor thickness, examined the running gear, found the wire still wrapped around the road wheels. They needed cutting torches to remove it. The wire had bitten so deeply into the rubber tires that it had scored the steel underneath. The suspension arm was fractured. The torsion bar was cracked. The mounting bracket was bent. Total repair time, 12 hours. Parts required, 1 torsion bar, 1 suspension arm, 2 rubber tire rings, 1 mounting bracket, all of which were available from captured stocks. The Tiger was operational again by evening, but it never returned to combat. Fuel shortages kept it immobilized for the rest of the campaign. By August, it sat in a depot south of Saint-Lô, awaiting fuel that never arrived. In September, the crew was reassigned. In October, advancing American units captured the depot. The Tiger was loaded onto a flatbed and shipped to the Aberdeen Proving Ground in Maryland for evaluation. McAllister's commanding officer submitted him for a Bronze Star. The citation was brief, bureaucratic language for innovative action resulting in the neutralization of enemy armor. The recommendation included witness statements from the platoon lieutenant and 2 sergeants, a sketch of the wire placement, photographs of the damaged Tiger. The paperwork traveled up the chain of command, reviewed at battalion, approved at regiment, confirmed at division. The medal was approved in August, presented in September in a formation in a muddy field outside Aachen. McAllister never spoke about it publicly. After the war, he returned to Pittsburgh, used the GI Bill to finish an engineering degree, worked as an electrician for 31 years. Union man, steady employment. Married in 1947, 3 children, retired in 1976, died in 1989 from complications of lung cancer. His obituary in the Pittsburgh Post-Gazette mentioned his military service in 1 sentence. Bronze Star recipient, combat engineer, Normandy to the Elbe. The obituary said nothing about the wire, nothing about the Tiger. His family knew he'd been in the war. They didn't know the details. But word spread among combat engineers. After-action reports circulated, the wire trick appeared in intelligence summaries. Field manuals were updated. By July 1944, engineer companies across the European theater were carrying extra coils of wire, not for communications, for traps. Some tried to replicate McAllister's success. Results were mixed. Wire worked against Tigers and Panthers when conditions aligned. Narrow roads, firm anchors, surprise, the right angle of approach, but it failed against lighter tanks with simpler running gear. It failed in mud where the wire sank before the tank reached it. It failed when tank crews learned to watch for it. German field manuals were updated in August. Warnings about cable traps appeared in technical bulletins distributed to panzer units. Crews were ordered to have 1 man walk ahead of the formation in close terrain. Cut any suspicious wires with machine gun fire before advancing. Post sentries at night to prevent engineers from rigging traps. The countermeasures were effective. By September, the wire trick rarely worked. Tank crews were alert. Engineers trying to set traps were killed by machine gun fire before they could complete the work. The tactics window was brief, June to August 1944, 3 months. But its impact was documented in after-action reports from 7 separate divisions. At least 11 Tiger and Panther tanks were immobilized by wire traps during that period. Not destroyed, not captured, just stopped. Forced to halt in exposed positions where they could be flanked or bypassed or destroyed by indirect fire. In the mathematics of armored warfare, a stopped tank was often as valuable as a dead one. It blocked roads, consumed resources, required recovery, tied up engineers and mechanics. The Tiger itself represented Germany's strategic dilemma: over-engineered, expensive, maintenance-intensive, tactically dominant, but strategically irrelevant. Germany produced 1,384 Tigers between 1942 and 1944. The Soviet Union produced 57,000 T-34s in the same period. The United States built 49,000 Shermans. Quality couldn't compensate for quantity at that scale. Every Tiger destroyed was irreplaceable. Every Tiger stopped was a resource wasted. Every hour spent repairing a Tiger was an hour not spent repairing 3 Panthers or 6 Panzerforce. The interleaved wheel design that made the Tiger so capable was also its downfall. Optimal engineering for ideal conditions, catastrophic in the field. The overlapping wheels distributed weight beautifully when clean and maintained. They jammed catastrophically when fouled. The design required piece to function properly. It needed smooth terrain, dry conditions, regular maintenance. War provided none of these. The bocage was mud and wire and debris. The Eastern Front was frozen mud in winter, liquid mud in spring. North Africa was sand and grit. Every environment exposed the Tiger's vulnerability. The wire trap exposed a deeper truth about complex systems. They fail in simple ways. The more sophisticated the design, the more fragile it becomes. The Tiger's interleaved wheels were optimal for weight distribution. They created vulnerabilities that simpler designs avoided. The Sherman's vertical volute suspension was crude by comparison. 5 road wheels per side, no overlap, no interleaving, just coil springs and shock absorbers. It provided a rougher ride. It created higher ground pressure. But it was also modular, repairable, resistant to fouling. A Sherman crew could replace a road wheel in 20 minutes with basic tools. A Tiger crew needed half a day and specialized equipment to change an inner wheel. This principle extended beyond armor. The Luftwaffe's Me-262 jet fighter was 100 miles per hour faster than anything the Allies fielded, but it required smooth concrete runways that Allied bombers destroyed nightly. The engines lasted 12 hours before needing replacement. The Panther's sloped armor was revolutionary, but its final drive failed after 150 kilometers on average. Germany's V-2 rocket was a technical marvel. It also cost as much as a 4-engine bomber and delivered a 1-ton warhead with poor accuracy. Germany's wonder weapons were marvels of engineering and studies in impracticality. They won battles and lost wars. They demonstrated technical superiority and strategic bankruptcy. They proved that sophistication without sustainability is a path to defeat. The Allies won with simpler weapons produced in overwhelming numbers. The Sherman was inferior to the Tiger in direct combat, but America built 50 Shermans for every Tiger Germany produced. Soviet T-34s were crude, but they arrived at the front in thousands, while German factories struggled to build hundreds of Panthers. McAllister understood none of this. He wasn't a strategic analyst, he was an electrician who knew how machines failed. He saw a gap in the wheels and thought about jamming it. There was no grand strategy, no sophisticated analysis, no deep understanding of German engineering philosophy. Just a man with 300 feet of wire and 90 seconds to act. Just the desperate calculation that anything was worth trying if the alternative was certain death. That was enough. The war didn't turn on wire traps. It turned on logistics, industrial capacity, and mathematics. The Allies won because they could replace losses faster than Germany could inflict them, because their supply lines stretched across oceans and remained intact, because their factories outproduced Germany's by factors of 5, 10, 20. Individual actions mattered in local contexts. A disabled tiger saved lives in one hedgerow, but 50,000 Shermans won the campaign. Still, the wire trap endures. It appears in training manuals at Fort Moore and Fort Sill, case studies at the Army Engineer School, technical analyses of track vulnerability at defense contractors, academic papers on improvised anti-tank measures, discussions among armor historians about the limits of sophisticated design. It represents something essential about warfare that transcends technology. Complexity creates fragility. Ingenuity finds weakness. Desperation breeds innovation. McAllister never claimed to be innovative. In his only recorded interview, given in 1987 to a local newspaper researching veteran stories, he said, "I just didn't want to die that morning. The wire was in my hand, the posts were right there. It seemed worth trying. I didn't think it would work, but doing nothing definitely wasn't going to work."
Worth trying. Two words that summarize battlefield innovation across centuries. Someone tries something because the alternative is unthinkable. Most attempts fail. A few succeed. The successful ones get remembered, analyzed, mythologized, refined into doctrine. The failures vanish into the noise of combat. No after-action reports, no medals, just names on casualty lists. The difference between success and failure is often luck. If McAllister's wire had been 6 inches higher, the tiger would have driven under it. If the fence posts had been rotten, they would have snapped. If the wire had been communications cable instead of the slightly thicker telephone wire, it might have broken. If the tiger commander had been more cautious, he would have sent infantry ahead to check for traps. If the ground had been softer, the tiger would have taken a different route. A dozen variables, any one of them different, and the wire trick fails. McAllister dies in the hedgerow. The tiger advances. The outcome changes. But the variables aligned. The wire was the right height. The posts held. The tiger drove straight into the trap. The mechanism jammed. The formation halted. Artillery arrived. The Shermans flanked. The Germans surrendered. McAllister survived. 32 men in a hedgerow lived to fight another day because one engineer saw a vulnerability and had 90 seconds to exploit it. The Tiger I was retired from production in August 1944. Germany shifted resources to the Tiger II, which had even thicker armor and even more complex mechanics. It also had overlapping wheels. The vulnerabilities remained. Allied engineers continued exploiting them. Wire, logs, chains, satchel charges, sticky bombs, anything that could jam the Laufwerk or damage the suspension. By the end of the war, German tankers feared track damage more than armor penetration. A disabled tank in enemy territory was a coffin. The crew could bail out, but they were miles behind enemy lines. Capture was the best outcome. Death was more common. McAllister's wire is preserved today at the Infantry Museum at Fort Moore, Georgia. It's housed in a climate-controlled case. It's displayed with a typed card explaining its use. The card includes a photograph of McAllister in uniform, a sketch of the trap's placement, a brief description of the engagement. Most visitors walk past it without stopping. The wire looks unremarkable. Frayed steel cable, rust spots, faded green fabric insulation. Nothing dramatic, nothing that suggests its significance. But it stopped a machine designed to be unstoppable. It proved that 56 tons of armor, 4 ounces of hardened steel, and 700 horsepower could be defeated by 8 ounces of wire applied at the right point with the right timing. It demonstrated that every system, no matter how sophisticated, has vulnerabilities, that complexity creates fragility, that sometimes the simplest solution is the most effective. The lesson isn't about wire. It's about seeing systems as they are, not as they're intended to be. The Tiger was intended to dominate battlefields through firepower and protection. It did, but it was also a collection of components under stress. Wheels and tracks and pins and brackets, each one a potential failure point, each one subject to the laws of physics and material science. McAllister didn't attack the Tiger's strengths. He didn't try to penetrate its armor or disable its gun. He targeted a seam in its complexity, found the point where sophistication became vulnerability. Modern armor designers remember this. Contemporary main battle tanks use fewer, larger road wheels, 6 per side on the M1 Abrams, 7 on the Leopard 2. External tracks that can be replaced without specialized tools. Simplified suspension systems that prioritize maintainability over optimal ride quality. The lessons learned from the Tiger's failures were incorporated into every tank design since. Elegance is valuable. Reliability is essential. Complexity without robustness is a liability when mechanics work under fire in the dark with limited tools. June 1944 taught that lesson in blood and steel. McAllister taught it with wire and 80 seconds of courage. The hedgerows of Normandy are quiet now. The sunken road where the Tiger stopped is paved. Houses line the route. Traffic passes daily. A small stone marker placed in 1994 for the 50th anniversary of the liberation commemorates the action. It doesn't mention McAllister by name, just the date, the unit. Here, American soldiers halted enemy armor. Generic language. Compressed history. Individual contributions blur into collective memory. But the wire trick remains in the professional military education curriculum. Not as a recommended tactic, wire traps are obsolete. Modern tanks have different suspension systems, different vulnerabilities, different countermeasures. But as a case study in creative problem solving under pressure. In seeing beyond doctrine to possibility. In understanding that every weapon system, no matter how sophisticated, can be defeated if you understand how it works. That understanding came at a cost measured in lives and years. Every tank disabled taught a lesson. Every engagement generated data. Every failure and success refined tactics. The wire trap was one data point among thousands, one innovation in a war defined by industrial-scale violence and rapid technological change. But it mattered. It saved lives that morning in June. It contributed to a body of knowledge that helped win the campaign. It demonstrated principles that remain relevant. A 56-ton tank stopped by a strand of steel and the courage to try.